So your next dot should be right there. So we would calculate the slope of our runner by looking at only 2 of those points and figuring out how much is the rise, what's the amount that they are going up by, and then how much are they going over their run. So if we look at points A and B, the rise from 400 to 800 is what? 400. How do you find that? Well, you take 800 minus 400 and you get 400. So the rise is 400 meters over how long did it take them? So from here to here, you had to go over 1, 2. You had to go over 2 minutes. So the slope of our runner should be m equals 400m divided by 2 minutes, or over 2 minutes. And I give you this. So here is where your point should have been, and then m equals 400 meters over 2 minutes. Sorry that it got cut off. That was a very, very basic baby graph. We aren't gonna do anything much more complicated just because I can't do it when we're distance learning. I will have some extra challenges for you guys, for those of you that want something more challenging, but a lot of this is going to be focused on a lab that I'm going to have you guys doing at home, and I'll explain it when we get to it. So let's go to the next one. Acceleration. Chapter 2 was all about slow motion. Basically all you have to know is that some of Earth's plates move at a rate of several centimeters every year, and others will only move a few millimeters per year. Basically, that slow motion is a thing and it exists. Section 3 is all about acceleration. So let's figure out what it is. Acceleration is the rate at which velocity changes. So the rate at which velocity changes. It can change in 2 ways, actually. The first change could be direction, and the second change could be speed. Speed can either increase or decrease. So, something that you're going to have to come up with is examples for change in direction, increase in speed, and decreasing speed. And there is going to be a Google form, a OneDrive form that I'm going to ask you to fill out with your examples. So, let's think of one together. And when I ask you for an example on the OneDrive forms, your example needs to be different from mine. So, a change in direction. Mozzie could be running at 50 miles per hour. Wow, that's fast. Let's change that. Mozzie could be running 5 miles per hour towards me, but then see a squirrel and decide to run away or run towards a squirrel. Okay, right there. That's a change in direction. You knew what direction he was traveling. You knew his speed, but then he changed. He went in a whole nother route. Increasing speed. A ambulance could be traveling at 20 miles per hour and go onto the freeway and increase to 60 miles per hour going north. Right there you have velocity. Remember, velocity is the speed and the direction. And you still need that in acceleration. So right there, the ambulance was traveling at 20 miles per hour, and then it hopped on the freeway and ended up going 60 miles per hour, following the speed limit, going northward or northbound. Decreasing speed. A sloth could be moving down a tree at 5 inches per hour and slow down to 1 inch per hour. Okay, that right there is an example of decreasing speed. So acceleration is pretty easy just because it's the rate at which velocity changes, meaning it's the rate at which some object is moving based upon their speed and their direction. And it can change direction, or it can increase its speed or decrease its speed. So when you are given a math problem, to solve for acceleration, you're going to calculate the change in speed per the unit of time. And this would be the formula right here. Acceleration equals final speed minus initial speed divided by time. And the time, or the denominator, will always be squared. Now, no. We are going to do an example. So let's look at this. Let's say you have an airplane that can go 0 to 60 miles per second in 5 seconds. What is its average acceleration? So according to the formula, acceleration is the final speed minus the initial speed. So what is the final speed? What should I put here? 60. Good. So 60 miles per second minus the initial speed, which was 0, over the length of time, which is 5 seconds. So the 5 should go down here. So then you're going to do your math, and you should get 12. 60 divided by 5 is 12. So your unit, or your answer, would be 12 meters per second squared. Whoops. Sorry. So again, let me say that. Your answer should be 12 meters per second squared. And I want you to put that in here. 12 meters per second squared. So it could be 12 meters per second. Or you could write it as 12 MPS or 12 M/S or 12 meters per second. Oh, I did that. Sorry, I meant M per second. So you have, let's see, 1, 2, 3, 4 different ways that you can write your answers. But I can't do it here, but the time should always be squared. So this should be, let's say we're going to write it as MPS. You should have a little tiny 2 up at the top. So it should be 12 meters per second squared. With acceleration, you are always going to square the time. Whereas for speed, time, and distance, you just need the answer. So just like you had those 5 examples or 5 practice problems of speed, I give you a few acceleration practice problems. And you don't have to. These are optional. But it's just to make sure that you know what you're doing and you kind of understand the math behind it. So that was all of chapter 1, sections 1, 2, and 3. Basically, I recorded this whole lesson just so that you can play it at your own speed. So let's say you don't understand something I said back maybe about this, where is it? The speed triangle. You can go back and play it over and over and over until it makes sense, until you're like, oh wait, I understand that. Or let's say you just need longer, like a longer amount of time to solve these practice problems. Go ahead, pause the video, stop, and go do those practice problems on your own. So these are all available to you. I just wanted to make sure that you guys weren't on your own and it wasn't like you were teaching yourselves, which is why I wanted to record my explanations. Like you're going to notice things from now on are going to be very bare bone, very minimal. And I know that you guys are all extremely overwhelmed with everything that's going on right now. So I'm trying to make it so that you're not spending like 5 hours on science a day. You know, like if you do all of your science on Mondays and you want to like knock out science and get it done with for the week, be my guest. But if you want to work on it, I'm trying to make sure you only do about 10 to 15, max 20 minutes of science a day. So that's why if you look at your lesson plans, it's only going to have you going through slides 1 through 5 and listening to me and explaining or like filling in your notes from there. So hopefully this helped you guys. If you have any questions or you are confused on something, don't forget to email me at jgonzalez@bishopmuseojh.org. I would prefer that you email me here at the school website because I do not check my OneDrive email. I am going to be using OneDrive to send out mass emails personally to you guys with these files and with the notes. But actually, I should leave that up there for you guys. But I check this email like 5 times a day. Actually, I check it obsessively. I'll just like, if I'm bored, instead of going on Facebook, I'll check my email. I'm an old lady. So hopefully this helped you. If you are totally confused or lost, go here and then don't forget, check my Instagram, teacher Instagram. And I will try to have videos and links up there and something to try to help you guys. All right. So, hopefully this helps. Miss you guys. Let me know if you are confused about anything. And see you for the next chapter.